So this is 6.2b, college algebra, continuing with ellipses and circles, and we're sticking with ellipses right now. And we're looking at example number 3, bottom of page 538. And it gives us the equation 9x squared plus 4y squared equals 36. Okay, so when it gives it to you that way, we know that it is on the origin. There's no long, drawn-out equation like we're going to get to in example 4. So we know it's on the origin. And we have to first of all pick which of these ellipses are we looking at. Well, let's go ahead and put this in this form here, and then we'll determine what we're going to do. So, first of all, I know that this has to be a 1. Okay, so I need to change that 36 to a 1. That's the first thing I'm going to do. So how do I do that? Divide both sides by 36. So I have 9x squared over 36 plus 4y squared over 36 equals 1. I'm going to reduce the 9 over 36 to x squared over 4. And 4 over 36 is 1 over 9, and that equals 1. Okay, so far, not too bad. There's my, let's get rid of that and move that up, because this is all I really care about. And then I'm going to write it in standard form as x squared over 2 squared plus y squared over 3 squared equals 1. Now notice, my y is over the biggest number. So that means my y-axis is going to be the longest, which means it's going to look like this. Okay, that's all you need to know. You don't really have to know anything else except that, because when you graph it, at least you know you got it right. We didn't have to know earlier in order to do the equation right. We just do the equation, a standard equation, and then we look and say, oh, well, which one of these is it going to actually look like? All right, so let's go ahead and start looking for A, B, and C. Well, A is going to be 3, because A is always the biggest of the two numbers. B is going to be 2. Major axis is vertical. Vertices then are at 0, -3, and 0, 3. Okay, so that's the highest and lowest point. And we know that, again, c squared equals a squared minus b squared. So c squared equals 3 squared minus 2 squared. So knowing that, we find that c is the square root of 5. Okay, when we do the math here. So 9 minus 4 is 5. C squared equals 5, so c equals the square root of 5. So then that tells me that my foci is 0, negative square root of 5, and 0, positive square root of 5. Okay? So then when I'm going to graph this guy, if I can, I'm probably not going to do it without erasing stuff. Let's just do it like this. We get A is 0, -3, 0, +3, and then my other one is at 2. And I know my foci are at square root of 5. You kind of guess where that's going to be. It's somewhere between 2 and 3. Whoops. And then we've got our nice little curve here that we draw. And there's our graph. All right, so let's look at ones where our ellipse is not on the y-axis, or the origin, that it does not have as a center point the origin, and go from there. All right, so here is the blue box on page 539. All right, so again, you know, the formula is the exact same as if the center is at 0, because if the center was at 0, it would be x minus 0 and y minus 0, and that's where we got our y squared over b squared, and our x squared over a squared is because the h's and k's would disappear because they're zeros. Well, now that we're shifting away from the origin somewhere else, our h's and k's are actually there. All right, so everything is done the exact same way. Our examples, our equations, are going to be a little more intense. So like for this one, example 4, going to look like that. Okay, so that tells you it's not going to be having the origin or the center at the origin. All right, so again, we're going to do the same thing that we did on the circles. We're going to do a double completing the square. So again, we're going to put our x's together. Our y's together, and we'll put the 21 on the other side. All right, one of the things that you're going to do here, before we complete the square, we can't complete the square with a number in front of there, but fortunately we can factor that 4 out. Like that. Oops, not like that. That'll be 6x. Okay. Alright, so that 4 is just going to kind of plug along with us. So let's do the completing the square for this. So I'm going to make a brace here. And we have x squared plus 6x, half of that squared is 9. And the same thing here. Y squared minus 2y, half of that is 1, squared is 1. Okay, equals negative 21. But what did we add to both sides here? We added a 9, we think, but actually we added a 36. Okay, this 4 is multiplied by whatever we put in here. So we have a plus 36 here, and we have a plus, just a plus 1 here. Alright, so what we end up with is 4 times x plus square root of 9 is 3. And then here we have y minus square root of 1 is 1 squared equals 16. Okay, now let's, we've got to make this. So now we're in the right place. We have the x squared and the y squared, but it's equal to 1, and I have a 16. So we have to divide everything by 16. So that gives me x plus 3 quantity squared over 4, because 4 over 16, plus y minus 1 quantity squared over 16, can't cancel anything there, equals 1. Alright, so that looks so much prettier, doesn't it? Okay, so this is where we are with our equation at this point. Now we have to put it in the right form. One of the things that's necessary to see is that which form is it? Alright, let's look and see which number is the biggest. 16 is bigger, it's under the y, a is under the y here, so it's going to be this one. It's going to be in this shape instead of this shape. Okay, so let's go ahead and keep moving along here. So this, whoops, this isn't negative. See how it's negative here? So we have to write it as x minus a negative 3 squared over 2 squared, because you have to change that to squared. And we're good with the y minus 1. It's already minus over 4 squared equals 1. Okay, so our center. Where is our center? The center will always be hk, negative 3, 1. Negative 3, 1, not the negative 1. We never bring the negative with us. It's just the number there. So our center is negative 3, 1. That helps us graph it. A is 4, B is 2, and the major axis is vertical, so the vertices are 4 units above and below the center because of the A. So therefore, we go ahead and continue on, and our C. Our C is C squared equals A squared minus B squared. I'm sorry, I've got a C there for center, and this C is not center, it's the foci is what that is. So we've got C squared equals 16 minus 4, which is 12. So C squared equals 12, or C equals 2 square root of 3. If you were to reduce the square root of 4, or square root of 12, you get 2 square root of 3. Alright, so then when we're going to graph this guy, we've got our center at negative 3, 1, right there. We have our A is 4, so I know that my 4 is going to be 4 above the center and 4 below the center. So 1, 2, 3, 4. So it's actually at 5, because this is at 1, so, and then 1, 2, 3, 4, it's going to be down here at negative 3. So that ends up giving me my major axis, right here to right there. My minor axis, which is my B portion right there, what is my B? Is 2. So I'm 2 away. 1, 2 here, and I'm 2 away here. So both sides of my center, I'm 2 here and 2 here, and again my A is 1, 2, 3, 4, is 4 up and 4 down, and my foci are 2 square root of 3, so they're going to be kind of up in here and down in here, but that doesn't help me draw my ellipse. So there's my ellipse. So really the main things you have to know on this is your A and your B, and that's and your center. If you know your center, your A and your B, you can draw this, because your center tells you that, your A and your B, and you've got 4 points then to draw your ellipse around. Okay, so that's pretty much it. This is not too terrible, especially when you're used to doing some of this other stuff. You know, it's probably kind of a relief after you've done, you know, the matrices and partial fractions and so much of this other stuff, that this might be kind of nice to get into something that's a little less intense. Alright, so that is it for section 6.2.